So we tried this problem here and we came across some issues. So here is the proposition. Let's say that you have to find the limit as we approach negative infinity of some function f. Now, if for whatever reason, if you don't want to approach negative infinity, you can approach positive infinity, but what you'll have to do is instead of x, this has to become negative x. So what we'll do for our problem is we'll change this to positive, but this, and this all have to become negative x. And so we switch the negative to positive. All these inputs became negative x. Now here, this is going to become negative 2x. Here, negative x squared is going to become positive x squared. So this is going to stay positive 4x squared. This will become negative 5x, and this will stay negative 7. And now, why don't we apply the idea of a conjugate? So let's multiply top and bottom. There's a 1 down here. Let's go top and bottom, the conjugate of this numerator. And we know that up here, when you multiply conjugates, that you really only have to multiply the front pieces and the back pieces. And one quick comment before we go any further. Notice that when I use the conjugate of this guy, I only switch the middle sign. I don't switch this sign. That stays the same. The operation here is what switches to find your conjugate. And so I did negative 2x times negative 2x, that's positive. Square root knock out. Positive times negative is a negative. The bottom stays put. Let's go ahead and distribute this and simplify. And then we'll do that thing where we multiply by the reciprocal of the strongest power in the bottom. So in this case, it looks like we're going to multiply by 1 over x top and bottom. So distribute 1 over x to these guys here, that's what you'll get. Distribute this to there and there, you'll get this here. And then recall what we did, where this guy is going to invade the square root, but when you throw this inside, you have to square this. So this will look like 1 over x squared inside of the radical. And then we can distribute the 1 over x squared inside. And then all these x's could get replaced by infinity. And we know that 7 over infinity is 0. The same for these pieces there. And so we're left with 5 over negative 2 minus the square root of 4. And so we're left with negative 5/4. So the lesson to be learned here is that a lot of times if you're approaching negative infinity, but you would prefer to approach positive infinity, do so, switch it from negative to positive, but all the x's become negative x. Now, am I saying that this is a technique that you have to do? No, but it is an option.